time for another DraftPhysics.com, DebatePhysics.com also. Video presentation. So a math and science guy video. Another one on gravity, which is strange. So I have the old picture of a gravity video where he's dropping something. And this is a 40-minute video, and I'm just very curious. And so well, it's actually longer than that. Anyway, so I just thought it'd be worth playing the video and just pointing out how, wrong. yeah. Gravity really has to be something that you explain. You don't just say, okay, there's a bent geodesic that creates the inverse square law, because we know the inverse square law. Well, I know that anything radiating from a spherical body will duplicate the inverse square law. So it's really simple in the sense that all you're saying is, instead of radiating the event, it's absorbing it. And it's not really, in the sense that all you really are is in a differential. And the simple truth is, it's just heat. So as I point out there, it's just radiation from the universe comes in, hits you, very discrete it is. So it goes into all of you, okay, and pushes you, all of you, kind of equally. Now, maybe it's not exactly equal, but the pressure ends up being equal, okay, going through you. And the fact is the energy coming from below you has to go through a lot of matter to get to you. And so it's a little tiny bit behind. So it doesn't show up right away. So there's a little differential that you're stuck in, okay, in terms of the pressure coming from below versus the pressure from the free, open universe. And it's really that simple. Matter slows energy down because it has to push the little electrons, and they don't go as fast as the speed of light. And that creates the differential. So the bigger the mass, the more mass between you, and it's always on an arc. So I'm getting hit by gravity all these angles. But the fact is an angle like this has a component down. So the component going that way isn't doing anything, but the component down is. And you can see there's no mass here. There's no moon over here or moon here. So the stuff coming in from the side is balanced because there's nothing slowing it down. So all the stuff pushing this way and pushing that way doesn't do anything to me. But the stuff pushing down does, because the stuff pushing up, okay, is a little bit behind. So it's really that simple. They've created this big convoluted pile of mush, very complex equations, all kinds of nonsense, to explain basically just the inverse square law. That's all that really exists. And the only thing you can argue about is, oh, there might be uneven clumps of matter. So this is also the joke, is that the physics actually does admit that there's places on Earth where there's a high density of high density matter, and those places gravity's higher. The Earth is a little thicker, wider at the equator. There's some more gravity there. That kind of stuff, where it's sort of just a giveaway that this is just about how much mass the force has to go through to get to you. And that's all that's going to determine this differential that you'll be pushed in. And you will be pushed. So this really does go back to, say, hundreds of years ago. I could have said something like this, and it would have been taken seriously, because they didn't have a bunch of woo in their physics yet. They did have a God problem, so you usually had to say, how did God do it? But the fact is all you're looking for is a logical, sensible, complete, simple explanation, and it seems like physics never wants to vote for that. No, they want it to be complicated so they can be lords of the complication, lords of the confusion, lords of the invisibility, because they'll never show you anything either. All right, so that's probably enough. I mean, so he says this is Newton's law of gravity, and again, it's the law is the inverse square law, so it's not like Newton invented something really. He just made it understandable that it's a real quantity, gravity, okay, the 9.8 meters per second, and that there's a constant, meaning that it happens to all material objects. So I guess that was the big difference for Newton. Newton was explaining that everything creates gravity that has mass, and everything with mass will be affected by a gravitational field. I think it's a fair description, but, well, yeah. So, leave us fix the volume. All right, I think we're ready to begin.
Talk about Newton's law of gravitation. This is part 1. So in the beginning, I'd like to describe Newton's law of gravitation, where it comes from. We want to also talk about how it fits into the other forces in the universe and learn a little something about how special gravity actually is. Then we'll solve a problem to get our hands dirty, so to speak. But mostly, this is a general lesson to try to get you to understand Newton's law of gravity, what I say, in your bones. In other words, have an intuitive feel for what the equation says. So you're not just plugging stuff in, you're actually understand what all of the different parts of Newton's law of gravity is.
All right, so let's understand. They think that Newton's law of gravity means that you can fall twice the time, only get twice the velocity, and yet you'll now have 4 times the energy that if you only fell for 1 second. So falling for 2 seconds gives you 4 times the energy that you would have gotten if if you fell just 1 unit of gravity. And that if you fall 3 seconds, that you'll have 9 times the energy. So it makes no sense at all. And it gets worse and worse. 10 times, 100 times the energy. Just insanely silly. Okay, and he's going to teach. Oh. Okay. So the intro, I probably should just block the intro, but let's just play it. About twice as long as it needs to be.
Now, before we actually get to Newton's law of gravity, let's take a big picture, right? There are, as far as the current theory of physics goes, 4, 1, 2, 3, 4.
Right, silly. Okay, so it's just all silly. They're trying to say there's 4 fundamental forces, and the idea is that no, there's really just one kind of thing, little discrete bits of crap going the speed of light. So all the stuff that you could call a photon of some kind, something moving the speed of light, some discrete little tiny bit of stuff that hits electrons and protons and makes them move. And the fact is that single force is the only force. And all you're really saying is this, look, if I put it at a frequency, it's a visible photon, right? Or it could be a visible photon. And if I give it some other kind of pattern, the polarization, other things that are polarized will see it, and it'll be called magnetism, right? So that's done. And what else is there, right? So there's nothing else except this idea that, this force has to go through matter, okay, the photons coming from all the rest of the universe, all the background radiation, you want to call it, all this stuff. If I put something in space and just stick my finger in space somewhere, there's a whole bunch of stuff that's going to bang into it. So the space isn't empty. It's full of this force crap flying through it, the photons and whatnot. And so that's the stuff that's creating gravity. It's the same force. Now the other force they have is the strong force and the weak force, and these are just silly made-up contrivances. The strong force is easy to debunk as meaning anything, just because it's basically just saying they know that the nucleus is very small, which means the protons have to be very close to each other, and they're mystified at how it's possible you get protons close to each other. And if you know anything about magnets, well, if I want to get 2 north-side magnets really close to each other, I just stick a south-side magnet in between the 2 north-side magnets, and they'll cuddle right up. So it's not a mystery, frankly. That's so easy to explain. And I can't even explain their definition of the weak force, because it has something to do with the electromagnetic force now. and so it's blended in somehow, but it can't mean anything to anybody. It's just mush. All right, so let's continue. So there are no four forces. Bullshit. It's just nonsense.
Forces in the universe. Every force that you have ever talked about, either in a physics class or even just in everyday life, can be explained by one of the four fundamental forces of the universe.
Right, so they can all be explained by stuff moving the speed of light, so you don't need to understand it as anything other than that. And clearly there's rules, okay, as I show in a charge demonstration, there's rules between electrons and protons that allow them to attract and repel, okay, but they're really simple rules.
Universe. Today we're talking about gravity, which is one of the four, but there are three others that I'm going to touch on because I want you to have the big picture. And the big picture thing that I want you to pull away from this is that gravity, the one that you feel like you have the most experience with, is actually the weakest of all of the other
right, so it's no weaker, it's just that it's being created by a different phenomenon, right? So if I'm in empty space, there's no earth below me, there's no matter that the energy of the universe has to go through to get to me. And the simple argument is okay, obviously I'll be in a balance because the universe is symmetrical, essentially. There's not some obvious more here and less there. Now, if I'm in the solar system, for example, we know that I'll drift in a direction because, Venus is going to be over here and Jupiter will be over here, and there will be a differential, and I will drift in some direction because there's going to be in some direction there's going to be a little bit difference in the gravitational pull. All right, but the simple argument is all I have to do is put something big very close to me. I'm going to go smash right into it because the force going this way can't get to me. Duh. It can't get to me on time. It's just the simple point. It's clear, it makes obvious sense that the force would be slowed down having to travel through a dense pile of electrons and protons. Duh. I mean, it really is that simple. And just look at all the neurons wasted trying to contrive all kinds of bizarre explanations for something that's it's really that obvious. And frankly, this was suggested back in Newton's time, but in Newton's time they really didn't have a good grok of speed of light. I mean, that was later in Newton's life. And the idea that there was this stuff, that the magnetism was moving at the speed of light and the gravity was causing effects at the speed of light, and everything was being affected by this force that was consistent in its speed. There is of the four forces he's going to describe, there's no distinction in their speed. So, it's a little bit of a stretch to say you have these bizarrely different forces, and somehow these bizarrely different forces all happen to move at exactly the same speed.
Forces that we know about in the universe. And not just a little bit. Gravity is millions and millions and millions of times weaker than any other force in nature.
So it's a silly comparison just because the electrons and protons are in fact the only universe. That's where the force really does its acting, is against electrons and protons. That's what they're moving. And we're so much bigger. We're trillions of times bigger as objects, and so of course we're going to be affected less by that force. It would have to, it would have to accumulate over, many trillions of electrons for it to do something to change how something as big as us is going to move. We need a lot of energy to move.
And that's something that surprises a lot of people when you hear it because we're stuck to the ground, we feel gravity and so on. Now, we're going to talk a lot about that and convince you that in fact it's not just a little bit weaker or maybe a million times weaker. Gravity is many, many, many tens of millions of times.
It's just silly, right? Because you can understand, you could put magnets on your feet. And it's going to be, you're going to need a very, very strong magnet to make it impossible for you to lift your feet, right? So it's going to have to be a lot of electricity used. It's going to be a lot of energy you're going to have to create this, very, very strong force, so to speak. There's nothing very weak about gravity because the Earth is gigantic and it creates a really substantial difference. And you can understand that the difference is perfectly reflected in the heat absorbed by the Earth. The Earth is hot as hell. Okay, it's melted. So, most of the Earth is in a molten state. It's a lot of heat it has collected. So it would be kind of idiotic to say it's a weak force when the amount of heat inside the Earth is an astronomically huge number.
Weaker than any of the fundamental additional forces. So before we jump into Newton's law of gravitation, which I promise we're going to get to very soon.
It's such a stupid comparison. It's apples and oranges. The force is being affected in a different way, creating gravity, than it is affected in creating charge, and that it is affected in creating magnetism. They're all different ways of manipulating the force. So there's no point in comparing them.
I'm going to give you the big picture.
All right, so listen up. State Farm.
Fuck. All right, should be back.
4 fundamental forces of nature. Of course, there could be another theory that comes along tomorrow and adds another force to this list, but right now,
Too ridiculous.
as far as we know,
Just subtract them now. You don't need. There's charge, and frankly, charge is how force interacts with electrons and protons, and it is a consequence of essentially that interaction, the charge interaction, that there is the capacity for the force to be absorbed by electrons and protons, move slower because it's pushing matter, all right, and that differential ends up creating the end product of gravity. So it's really, you could say that the elemental function is charge, that is the ability of the force to interact with electrons and protons, and the consequential force is gravity.
everything in the entire universe can be explained by one of these 4 forces. First, we have the strong nuclear force.
All right, so it's just a mockable force. So they contrived it first. When I was a kid, they just talked about it as being something that pushes protons together, and they called that the strong force. Then they converted it into some sort of strong force that somehow makes the protons and electrons pull into each other. Okay, but it's just contrived. None of it has any, it's not either intuitive or is it some well-evidenced, they have a whole bunch of circumstantial evidence that points to the existence of some mechanism doing any of this nonsense. And it only happens because they have this wrong conclusion that the nucleus of an atom is all protons and something called, neutrons, which they think are neutral, that they don't have any other quality. And so they already know now that the neutron decays. They knew this in 40 something. The neutrons decay into an electron and a proton. So they already know that the positive and negative elements are both in the nucleus, and you can just understand that, yes, all I have to do is put 9 north side magnets and 18 south side magnets, and I can create something that'll be stuck together. I can create a nucleus. So the fact is the nucleus is net positive. It has twice as many positive elements than it has negative elements, but it has negative elements, and they're in the form of the neutron. I mean, it's just so obvious. And so there's no need for a strong force. Protons stick to electrons without any need to push them in. They want to be there.
I'm going to talk about it in just a second, but it has to do with the nucleus of atoms. Next, we have the weak nuclear force. All right, so these are both nuclear forces.
So I can remember, 50, 60 years ago when I was in school, that one still remained, what the hell are you talking about? What? Indecipherable explanation for what the fuck that other force is. Anyway, so, and then obviously photons was really easy to understand. Okay, I get photons.
Next, we have the electromagnetic force.
And that's just photons. And photons that are either doing magnetism or photons that are doing electricity.
Right? This is electricity and magnetism, which you typically learn as two different forces, but actually we know electricity or electric force and magnetic force is really part of a single force called electromagnetic force.
Well, it's silly to say that, though, because obviously they're very different phenomenon, okay? I mean, you can't bend electricity. Yeah, I mean, you know, you can't bend a magnetic field. You can't, you know, there's all kinds of rules. You know, with gravity, you can't do this, you can't do that, but somehow you can bend light photons. I mean, so there's all kinds of distinctions you got to recognize that do exist.
And then we have wimpy little gravity at the bottom. Right? And when I say it's weaker, it is many, many, many tens of millions of times weaker. So this is...
So again, there's just really no point in saying it when it's moving gigantic planets and solar systems and galaxies in the universe. It's just kind of insane to say it's a weak interaction. But the fact is, it's made out of a density of force that is insane. We just don't realize how much... I mean, you can know that there's, okay, I can say there's 100 billion neurons, cells, gigantic cells made of billions of atoms in your brain. I mean, it's billions of hundreds of billions of discrete little bits that we're made of. We are gigantic machines relative to the elemental universe of empty space, electrons, protons, and the field of energy. It's, yeah, we're very, very big.
The weakest of all.
And it's amazing that something can move something as big as we are. You have to kind of understand it's an immense amount of energy that moves us. Immense amount of little discrete bits of force have to be collected and move in a direction to oblige these huge objects to move.
Of these four forces. Now, this is not a class in nuclear physics, right? I just want to take 2 or 3 minutes so you can appreciate what we have learned, we being collectively humanity.
So they haven't learned it, they've just accepted it as a dogmatic religion, and they really haven't talked about any of it. They've just closed the subject. We've decided this is the theory we're going to live with and defend. We're going to build our house on this crap, and that's all it is. And it's a swamp that they've built a houseboat on. You know, they're floating on it, but it's not, you know, it's not a legitimate foundation.
Our tiny little brains have managed to figure these things out through experimentation.
No, they haven't. Okay, so what experiments? You know, this is again just bullshit. You haven't done a single experiment demonstrating mv squared to be real. A single credible experiment. You haven't even dropped 4 pounds 1 foot and 1 pound 4 feet. So when they say they've done experiments, they haven't done crap. Okay, 400 times better seeing resolution in space. And we're supposed to believe, even though we've been in space for 50 years, that no, we're not going to bother redoing the Eddington experiment. Only takes 5 minutes, costs well under $1,000 to do, and they haven't even tried. We're supposed to believe that that's their science, their well-evidenced science. Bullshit. It's just a religion.
All right, so the strong nuclear force, the top one on the list, it's, as you might think, it's the strongest of the four forces.
And the most silly, contrived pile of nonsense. So again, the current theory is something called a gluon, as far as I know, and it's supposed to be some sort of mechanism that shoots a tongue, like a frog. It shoots its tongue out and sticks it to a proton, and then pulls the proton towards it. Yeah. That's their science. Yeah, sorry, I gotta take a nap. That was just, that hurt so much. I have to get over it. All right, I think I've recovered.
You think about it, you know that this force, the electromagnetic force, you can have electric repulsion and electric attraction, right? So when you
All right, so I do have a simulator on the draft physics, debatephysics.com. There's a video called Simulation. It's also on the YouTube channel if you search for it. But anyway, and it explains, 3 really simple rules, absorption, reflection, and transition for the force bits hitting electrons and protons. And you can perfectly simulate charge. So you can explain why electrons repel electrons, why protons repel protons, and why protons and electrons end up attracting each other, moving towards each other. So, frankly, everything else is just an extension of that function.
you think about it, in the nucleus of all the atoms, you have the protons, right? You also have neutrons that don't have any charge. We have the protons, which are positive.
Yeah, why would the neutrons be there if they were truly neutral? So it's just a simple logical question, right? Why would something neutral be stuck in the nucleus? It wouldn't be attracted, it wouldn't be repelled, it wouldn't be motivated at all. Why would it be hanging out in the nucleus? Why would it be there?
Charge. But you learn.
And why would you have to have a nuclear chain reaction to shoot neutrons out? Come on. This is ridiculous. Why would they be that stuck if they weren't made out of this elemental charged substance and part of the charge phenomenon? Clearly, they can't be neutral.
And that this electromagnetic force, or this electric force, you want to think of just an electric force, 2 positive charges should repel each other. So the nucleus of all these atoms are full of positive charges, and even as a kid I wondered, well, why doesn't the nucleus just explode? Well, the nucleus is always trying to explode of every atom, even my skin, everything.
So it really isn't, because if you understand that electrons and protons are attracted to each other and that there's a tension, a balance between these attractive forces and these repulsive forces. So again, you can just do it with magnets, north-facing magnets. If I put a south-facing magnet down here, you'd understand how they'd both tip down, and they'd have to find a relationship. The 2 positives, the 2 north sides, aren't going to stick to each other. They're still going to be repelled, so they're going to find some place, to normalize. And that you could understand that if I had 2 separated by a distance, 2 south poles, and I stuck a north pole in between, they would just snuggle right up. So, there's lots of vector dynamics to how dipoles move when affecting each other, how magnets move in magnetic fields, and all of that has been well studied because we can see it. So this isn't at all complicated, that those are the forces binding things together. So all you have to do is accept that, well, the nucleus is net positive, but it isn't just positive. There's obviously negative elements that are holding it together. That's the glue, the electrons. Rutherford believed there were electrons in the nucleus. So the guy who started all this nuclear physics, it was completely comfortable with the idea that there's electrons inside the nucleus. And they're in the form of a neutron. The neutron wasn't discovered until after Rutherford's, stuff. But I'm just saying, it's just so obvious that the neutron is only neutral because from a distance it's got both elements, so it's going to look, say, purple. But if you get up close, you'll see the blue and you'll see the red.
It's trying to explode all the time. But it turns out that there is a deeper force inside the nucleus, not related to electricity or magnetism, called the strong nuclear force.
And it's bullshit. So he's saying this like he knows it. Like somehow he has had personal experience with the strong force. And it's just so wrong. They just made it up. It's a hobgoblin. It might as well just be called hobgoblin, the strong hobgoblin. I mean, it's nothing. It's not physics. It's not science. It's not real. It's a bad explanation. It's a wrong theory.
Right? The details of how it arises goes into the theory of quarks and such, and That's what protons and neutrons are made of, but we're not going to get into that.
So again, bullshit, they're made out of anything. At the time, they they always exist as protons, and you could argue neutrons, again, are the first dipole, electron and proton. And they always behave as protons. So to say that the proton behaves like quarks is bullshit. It behaves exactly like an electron except inversed in its function. And there is an indication that the reason why the protons are in the nucleus is because they're heavier, and that's the only distinction. So from space, in space they look the same because their charge is identical, and it's just that protons are heavier. They're harder to move.
Here, there is a deeper force that's much, much stronger than electricity or magnetism that actually holds the nucleus together, even though...
So it's a force made of nothing, a force with no mechanism, no physical mechanism. So they call this physics, and there's no physical mechanism.
Positive charges are trying to blow the nucleus apart. That's why it's much stronger, and so it's called the strong nuclear force. Without the strong force, there would be no atoms at all, of any kind. Any atom, calcium, magnesium, none of them...
So this is just such bullshit, right? Because it's just so simple. Just shove some electrons in the nucleus, problem solved. Let's move on. And it makes perfect sense. If the nucleus was completely positive, you'd understand that the electrons couldn't orbit on the outside. They couldn't be in a position on the outside. They would be so immediately attracted to the nucleus. And so the whole thing that keeps the electrons on the outside, the orbiting electrons that aren't really orbiting, the whole reason they can exist is because there are negative charges inside of the nucleus that are creating positions where, yes, it looks more positive, but there's an electron over there and an electron over there, so the electron can't get any closer because its repulsion to the electrons is balancing its attraction to the protons. And that's why they're stuck on the outside of the nucleus. I mean, it all fits and works, and yet they just keep preaching this crap that's just made up by whatever 50 people decided that you're supposed to believe this crap.
Would exist, okay? In fact, if you make the nucleus too big, physically large, right, where the strong nuclear force cannot reach out and grab onto it, because even though it is the strongest force, it is a very short-range force. It only acts over very, very tiny distances, the strong nuclear force.
It says them again. It's just bullshit. So the reason why, once you start getting bigger and bigger is you can understand the distance between the protons and the electrons as you make this spherically bigger and bigger would get larger and larger. And now, yeah, it's not going to work because now freaking electrons and protons could just find locations to crash into the nucleus.
Force. So if the nucleus gets very large, like in uranium, right, or plutonium, or any of these radioactive elements, then the strong force has a hard time holding the nucleus together and the nucleus begins to fall apart.
That's not what's happening. So the nucleus is falling apart because it's vulnerable to something being able to actually crash into it. It's more vulnerable to being hit. Where the smaller the nucleus, the stronger the electron and proton forces are, and the harder for any charge to be able to penetrate.
We call that radiation. So if you have a radioactive element, particles are coming out of it because it cannot be held together very easily.
So the nucleuses of the atoms are not particles coming out of it, okay? That's not happening. Every atom of uranium isn't shooting a bunch of crap. That's nonsense. Okay, it's only that every once in a while one of the millions of atoms explodes, like a supernova in space or something. And that one explosion is so intense that it produces a ton of radiation that flies out. So it's only 1 in a million that's blowing up at any one moment. And so it's just nonsense to say that every uranium atom is sitting there going, I'm radiating. No, they're not radiating anything. They're perfectly comfortable. And then one day they fall apart and explode. That's it. The whole atom breaks and it turns into different kinds of substances. So, I mean, it's just wrong to imply that every radioactive atom is radioactive all the time. It's not. Most all of them. I mean, you could say 99.99% of the uranium in uranium is not poisoning you. It's only 1 out of a billion atoms that's poisoning you.
Even with this strong force, the nucleus is just too big. So large elements at the bottom of the periodic table, they have a hard time staying together.
So it's just wrong. They stay together uranium stays together for 10,000 years. It has a gigantic half-life, so it does very well, staying together. So again, it's just nonsense.
Call them radioactive. So that's the strong nuclear force. The weak nuclear force, I'm not going to get into the details, but
Yes, because they aren't even comprehensible.
To do with radiation. The weak nuclear force is involved in when one particle turns into another particle. There's
so nothing turns into another particle. Okay, you can just change an atom, the structure of the nucleus. You change the structure of the nucleus and you can change whatever, uranium into barium and something else. So, I mean, smaller nucleuses. But there's no particle changing into another particle. That is just bullshit.
We call it a weak nuclear force, which is involved in that process. But so it's all happening inside the nucleus as particles decay and so on.
Nonsense. Nonsense, 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 nonsense. Again, there's no particle decaying. So again, it's just nonsense.
And then you have this electromagnetic force. So two magnets repelling, two magnets attracting. We call it magnetic forces, but we also have electric forces.
So it's the same thing, right? It's the same force moving the speed of light, and all you're saying is somehow the pattern's different. Only magnets can see magnetism. So only a magnet can be affected by it. Only a polarized configuration of electrons and protons can be affected by a magnetic field. And that just means that the pattern is only visible if you have if you're likewise in a position to be polarized and moved. So if you're not a polar object, you can't be affected by the magnetic field, because the magnetic field is just a change in a field, a pattern in the field, and you got to see it or not see it. So I've used a bullseye example, that you could have a bullseye that has a red center and a blue ring, or you can have a bullseye that has a blue center and a red ring. And that's what the field is. And if you're polarized, then you can see the red-blue and the blue-red difference. And if you're not polarized, you can't. All you see is purple.
Positive charges, repel. Opposite charges retract. Electron and a proton, for instance, will attract each other. So we used to
think... And they have no theory of how that happens. And so that's, again, my point. The simulation, I've got a simulation that shows how simple it is. All you have to understand is there's two kinds of force, electron force, proton force, but same force, same speed, same magnitude. It's just that one's a triangle and one's a square, or one's red and one's blue, whatever the distinction is. And there's electrons and protons, and the electrons can see the electron force and the protons can see the proton force, but the protons can't see the electron force, and the electrons can't see the proton force, and that's the interaction essentially.
Think that electricity and magnetism were separate forces, but actually we now know they're unified and all part of a single force called electromagnetism. And
so they don't know any of this stuff with any degree of what they're claiming as their certainty. So again, it's just all hyperbolic. They're all just, pretending they have real hard evidence indicating this hobgoblin theory they have invented is real, and it's not. This is just a Smurf theory or a SpongeBob show or Sasquatch, pictures. This is UFO science. This isn't real science.
In fact, we can make disturbances in the electromagnetic field, and we call those electromagnetic waves disturbing the field.
So it's just nonsense. Nothing's waving. It's not disturbing the field. The field is, you're by your own definition, creating the effect. So again, it's just, saying this stuff all backwards, and somehow it knows how to do all of this stuff. So this elemental dumb universe made out of these simple constituent elements somehow knows how to create all of this wacky curvy, smurvy behavior. No, it doesn't.
And we call that radio waves or microwaves or gamma.
It's all vectors. Vectors answer the question. It's all straight line force. It's just nonsense to talk about this wavical bullshit.
Or waves or whatever whatever you want to talk about, but any disturbance in electromagnetic field, we call it photons of light. We call it light. That's what we call it, or radio waves, right? All the same deal. But anyway, all three of these are many
not exactly the same deal. I mean, the radio waves, we know you can't just, there are certain rules. Metals pick up radio waves really well, conductors. There's rules about this radiation and what can possibly see it and how it sees it. So you do got to make some distinction about how it's created. Antennas create radio waves. Little tiny atoms, discrete little tiny atoms, create photons.
Millions of times stronger than wimpy old gravity. That's what we're talking about here.
So there's just no point making this ludicrously silly comparison and trying to say that these are individual, different, distinct forces when it's all made out of exactly the same stuff, a field that already exists in the universe of little bits of energy. That's the energy conservation. You can never change how much energy is in the universe because it's all in one form of stuff moving. And the stuff moving has to stick to matter. Electrons and protons give them motion. And that motion is slower than the motion that the force is moving, obviously. A Sisyphus is rolling a boulder. A Sisyphus is running a track meet. The Sisyphus not pushing a boulder can go very fast. The Sisyphus pushing a boulder has to go much slower. That's the simple logic. It's not confusing at all. And it's all tied to momentum. It's all about masses and velocity. So give the force bits a very finite small mass, and you just have mv in the field of force, and then some of the mv can be in the form of Sisyphus, force pushing matter, and that's where so the force is in two conditions. It's either flying through space freely at the speed of light, or it's pushing an electron and proton. And that balance always exists. If there's less in the field, then there's more in the pushing the matter. And if there's less pushing the matter, then there's more in the field. And that's the balancing agent. It's just, it's all so obvious when you start. If you just start from the simple, Newtonian, Descartesian, Galilean foundation and just resist going wooey, you can answer all these questions. I mean, there's no need for these silly answers. These desperately silly answers. Continuing.
Gravity has the distinction of only being attractive. It's only attractive, whereas electromagnetism can be attractive or repulsive.
Right, so gravity is only caused by one mechanism. It can't make more force. All it can do is take force away. So all it can do is create this differential where the force trying to get to me from the rest of the universe down there has to go through all the other people on the other side of the earth and all the ground and all the stuff and everything and through the center of the earth and through all the other matter still there to get to me. And the fact is, it's slowed down a little by that process. And that little tiny differential of this is hitting me now, that's going to hit me a little later. That differential is what we're constantly being pushed into the earth with.
And in fact, electromagnetism...
Tis unfortunate. I think you ought to just have one long commercial and just get rid of all these little shit commercials.
Specifically, the electric forces between electrons and such are the entire reason that chemistry exists. So any kind of chemical reaction, burning something, any kind of chemical reaction in your body, turning food into energy, releasing heat, releasing energy, anything.
Energy. Heat is energy, so let's just understand that is all there really is. Heat is photons. Obviously, right? I mean, we call them infrared. That's heat, radiation, we call it. Well, guess what? Visible photons are just as hot, and ultraviolet ones are just as hot, and gamma rays are just, X-rays are just as hot. So it's just stupid, because the ones we can't see, we just call them infrared, okay? But the other photons of higher frequency have exactly the same property as those photons. Microwaves have the same property, essentially. So we know they all can generate heat. All of them.
Where a chemical reaction is taking place is involving the electrons changing positions in the compounds you have. All of that is due to electric forces. So it's all
Okay, so it's all due to charge. So it's not electric, it can be magnetic. And I would argue that charge is clearly a magnetic phenomenon. The electron is in a magnetic monopole. It's the north. And the proton is the south, and that works just as good as plus and minus. And you can understand that the atom is basically just a configuration of magnetic bits, and they don't need to do any orbiting. Orbiting is superficial, no, superfluous. It's completely unnecessary to imagine that they need to orbit to be in positions around the nucleus, and it would defeat the whole purpose if I'm right about the nucleus having electrons in it. The orbiting would mean that it can't see the positive and negative fields anymore.
all wrapped up in this electromagnetic force. When your muscles move, you say, well, what force is that? Well, that is a chemical reaction inside my arm, right? So that is an electric force. Electromagnetic force is what governs.
Oh, so again, he says it's electrical, but really, this is again one of these arguments where you could say, okay, it's ions moving across the muscle fibers, and those ions can be argued to be polar atoms, and so again, you're back to magnetism.
That. You might say, well, what about when I push on the board? What force is that? Well, the resisting that I feel is from the flexing of the board, and that's the attraction.
So we don't get any flexing from the board that we can feel at all, so that's more nonsense, and we're banging into electrons. And clearly there's a lot of motion. The pressure does create motion in the electrons, but obviously the electrons push into each other and create a reverse pressure. They pressurize, and they say, well, the more you push in, the more pressure you're creating inside of us, and we're going to push back now because you've put more pressure. We have a higher pressure than the pressure you're applying, so you're not going to push any further. And that's the simple explanation. Everything all atoms are elastic. There's no such thing as an elastic atom. There's no atom that's incapable of being pushed on and it pushing back. They're all spring-loaded.
Between the atoms, and those are all electric forces, right? When I sit in a chair, the chair is pushing up with a normal force. Where does it come from?
So it's not a normal force, okay? It's the resistive force that you created by pushing in. You made more pressure on the surface of the earth. You increased the pressure of the entire surface of the earth, essentially. And that increase in pressure is just saying you can't go any further because we have a higher pressure than you're applying.
It comes from deforming the material of the chair, and it springs back. Those are all
So it springs back because you've increased the pressure.
electric forces. So actually, most of the forces that you experience in everyday life, other than standing on the ground from gravity, they're always due, or almost all of them are electric forces. Any pulling on a rope.
So again, this, it's not worth fighting it over and over again, but it's wrong to say it's just electric. The function is charge, and charge creates electricity and magnetism.
Pushing on a couch, any of those, kicking a ball, those forces are all basically microscopic electric and magnetic forces. Gravity is the odd one out because it's only attractive, and gravity can act.
So again, there was nothing attractive by pushing. So it just pushed back. So, where's your argument there? And so the charge function is the one, yes, the electrons are repelled by electrons, attracted to protons. So that's different rules. But again, that's what you're doing when you send any energy through electrons and protons is that, yes, you're pushing on electrons and protons. So, of course, if you're pushing on both of them, you're not going to see any differential. You're not going to see a charge phenomenon. You're just going to see the fact that you're moving matter, and the matter moves slower than the force.
Over a very, very far distance, right? So we're going to learn what the equation predicts, but what we're going to know and just kind of think about is that according to Newton's theory of gravity, every object in the universe.
This wasn't only Newton, so let's just understand some of this simple stuff. The R² part was argued by Newton and a lot of other characters, and Newton even acknowledged that. So that part wasn't Newton. I mean, Newton's part was saying that every material object in the universe is doing this thing, this concept of gravity, was generating this differential. Any piece of matter moving in the universe is changing the gravity in the universe, changing how much pressure is in the universe in certain locations. So any location is going to decide which way the pressure is decided by how much matter there is interfering with how much force is going to hit you. How much clear space there is versus material space. The material space is less pressure than the empty space.
That has mass is attractive to every other object in the universe. So this pen is attracted to my head. This pen is also attracted to the board. The board is attracted to the pen. The board is attracted to my head. The pen is attracted to the camera. The pen is attracted to the...
So there's no point in saying all this crap. You're just saying that every single material object absorbs some amount of force, okay, in this one moment. And so at any one moment, everything in your environment is absorbing energy. And the only place that isn't happening is some place where you can see without there being any matter in the way. And you know, that's where the force is the strongest, and everywhere else it's a little weaker.
Time. The pen is attracted to Alpha Centauri 4 light years away. This pen is also attractive to another galaxy.
So you're being pushed by the black space, right? And you're being attracted by the white space. So if you look at the stars at night, where it's black, it's pushing on you, okay? And where it's white, it's attracting you. This is one way of looking at it.
Galaxy many millions of light years or hundreds of millions of light years away.
It's just pressure. There's more pressure where it's black and less pressure where it's white. I mean, you know.
Every object is in attraction with every other object in the universe.
So nothing's being attracted. It's just about taking away the push. So you're taking away the even push. You're putting a pillow here. So there's a Muhammad Ali or a Joe Frazier or a Mike Tyson punching me from this side. And I have a pillow over here, and the punches can't get to me. And that's all gravity is. It's a push, 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 push. It's not a pull force.
Right? Now,
so they won't even have that conversation. I mean, it's so elemental to understand the universe and say, well, what's elemental, pulling or pushing? And even that question is so obvious, there's only one rational answer. Push is really easy to understand elementally. Banging one thing into another, having it bounce off or having it stick, you know, whatever. But the idea of one thing interacting with another thing and causing an interaction, really easy to understand. An interaction where I don't have to touch it, I don't have to go near it, I just say, come to me. That's bullshit. Clearly not even close to understanding that as an elemental function. That something can just tractor beam without a force, without a mechanism, without anything, just tractor beam. Just a switch, not wired to anything, and just hit the switch and it tractor beams. I mean, it's nonsense.
It gets weaker, the force gets weaker as things become separated, but the attractive force is still there according to Newton's law.
So it's a push averse, okay? So again, the attractive force isn't mean there's something attracting or pulling. It means there's an absence of push.
Law of gravity. Now let me just stop for a second and say that the point of science really isn't to know the truth, right?
Oh, fuck you, man. Oh, sorry, I gotta go. Gotta take a break after that. Damn it. That's disgusting. No, that's the only point of turning your brain on and thinking, is to think accurately and reliably and coherently to reality. If you're doing something else, then you're just wanking. You're a cartoon character. You're wasting neurons. You're an insult to intelligence if you're not trying to know the truth. All right, a little coffee courage, so let's try it. The point is, it's not the truth. That's what he just said.
Always want to know the truth, but in reality, we know that we may never know the real truth. What we really try to do is build better and better models of reality.
Oh, okay, so the better models mean ones that are more aggrandizing to human beings and make it more fun. You know, banana cream pie. Let's have that for dinner. Let's pretend vegetables. Oh, fuck that. Fuck this. Fuck. We'll just eat our sprinkles, and glitter. And live on that. I mean, it's just such a pile of shit. What's fun? Not what the truth is. No, let's have the fun physics. He did a video on farting, for fuck's sake. I mean, shit. 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 I mean, shit. They don't have a clue what's going on. They just really have no fucking clue. And they're just pretending, I'm intelligent. And I'm going to tell you what we intelligent people have decided the truth is. And it's just stick up their ass crap.
That predict reality better and better. And the better and better...
So what does that even mean? Predict reality better and better with a cartoon. I mean, it's just nonsense.
You predict reality, then the better we say your model is.
Yes, well, your model sucks. It plainly sucks. Okay, I mean, bent space. I mean, again, I can't believe it took me 65 fucking years to figure out that, well, duh, gravity's creating a ton of heat. So, how does the heat get back into a bent geodesic? Huh? What the fuck? Yeah, there's no explanation how the heat is absorbed by the bent geodesic. No, it isn't. It isn't.
Is the model really truth? Like, is it really work according to Newton's law?
Oh, so again, he just keeps saying, does the model work? And that you haven't tested 4 pounds dropped 1 foot and 1 pound dropped 4 feet. Haven't done a single fucking test. Haven't trashed cars. Haven't tied trains to each other. Haven't done a damn thing to validate any of this fucking goddamn religious crap. This silly holy ghosty theory. Hobgoblins and pixies.
Gravity, for instance? Well, no. We know that Einstein came up with a better theory of...
So just puke. There's no theory. There's no mechanism. It's just some stupid statement that, well, the inverse square law is created by a bent nothing. Yes, there's nothing, and it's bent, and that's creating it. That's an explanation that has some hope of being the truth? Fuck. Oh, that's just amazing. They're so obnoxious to tell me it's a better explanation. It explains nothing. It's not a mechanism. How can it explain anything when it's no theory of how? It just does with the bent space power. Bent space power! Like Power Rangers or something, or Pokemon? Gravity boogie? Some little boogie, and we call it gravity. Some little whatever weird Flamangi character.
Gravity. It's called the general theory of relativity, and his theory of gravity involves curving of space and time.
It's just a big pile of crap. It's a silly drawing of the inverse square law. It doesn't mean a damn thing. And there's no mechanism. And he creates a fourth fucking idiotic moronic dimension that's not obeying any of the rules. Dimensions have to form a right angle to the other dimensions, or they're not dimensions. Shit.
that gravity maybe is not a force, but maybe it's a geometric folding or bending of space.
Oh, but just a folding of nothing.
And time, right? And it turns out that Einstein's
Shit, I know it doesn't turn out. It really doesn't. It turns out that you did 3 experiments and you assumed that atomic clocks can't be broken. That somehow you could never change the decay time of an isotope. When you already know that, well, sure you can. Just put them close together and the decay time's cut in half. This is just such bullshit. One could imagine that velocity could disrupt the process, whatever it is, that instigates the decay event. The decay event doesn't happen because each atom is saying, I'm 99.96 years old and in 3.7 minutes I'm going to decay. That's not how decay happens. Decay happens because the environment is causing it. And it creates this little improbable event, whatever it is. Two pieces of force hit the atom at exactly the same time from exactly opposite locations, and this splits the atom. Some event like that. And you're just saying what could make that event happen more often, what could make that event happen less often. So, I mean, it's just such bullshit to say they have any reason to say we've proven this crap. You haven't proven anything.
theory of gravity
There's lots of reason to fucking doubt.
is much more accurate when calculating things.
Bullshit. Bullshit. No proof of that either. So where's your more accurate calculation? Show me Einstein's field equations used to calculate the orbit of Mars and explain how you get a better answer. It isn't a fact. They don't get a better answer
Than Newton's theory of gravity. So we think that Einstein's theory of gravity is much closer to the truth.
So again, it's just absolute bullshit. All Einstein's theory does is create noise. This huge giant equation creates a little bit of noise, and a little bit of noise explains why Mercury is fucked up, because Mercury is a lot closer to the sun. So any noise you create in the sun's motion will cause Mercury to process in its orbit. And because the other planets are so much further away from the sun, the little tiny precession can't affect them. There's no evidence that Mercury's precession affects Venus at all. So again, this is just such bullshit.
But we also know in modern physics that we have quantum mechanics. And according to quantum mechanics, which does not include gravity, everything else is it comes in chunks. Like a photon of light comes in a chunk.
So this is bullshit. That's not quantum mechanics, okay? Quantum mechanics is Schrodinger's wave equation. So what are you talking to me about? You believe it comes in chunks. That's not quantum mechanics. Quantum mechanics is that even an electron isn't a chunk anymore. Oh, I mean, they can't even describe their own nonsense consistently. Pathetic.
We call it a quanta of light, a single particle of light. Electrons come in little chunks, little single chunks of matter.
No, again, that's not quantum mechanics. They don't come in anything. It's a sparkly, wooey, superimposed, we can't tell where it is bullshit. It has nothing to do with being a fucking particle theory, for fuck's sake.
Protons, quarks, everything seems to come in chunks. That's called quantum mechanics, right?
Yeah, that's called bullshit. What you just said just proves how this physics is nonsense. But I just play fucking goddamn Sean Carroll or any of the other wooers, and they're not going to say quantum mechanics is about chunks.
So maybe gravity should come in some chunk. Maybe there's a particle of gravity. Maybe
Maybe. Maybe it's like everything else that's going the speed of light. It's in little bits of crap. That's everything screams the very fact that it's a field full of little discrete bits of momentum carrying crap. That's what the fucking field is.
gravity should be folded into quantum mechanics like everything else. And so scientists are working on that, and we do not...
Okay, so all these scientists are working at it, and none of them have noticed that the Earth is molten, and that there's zero explanation for a cause for that fact beyond the fact that gravity's doing it. That's what all that pressure, all that weight being pushed into the center is creating an extreme pressure. Pressure makes things hot. Duh. I mean, duh.
Have a unified theory of gravity. We do not have a quantum theory of gravity.
Yeah,
but
you don't have any theory of rational motion in the universe. And you can't even, again, you claim there's this quadratic increase with velocity in your energy, and yet it doesn't move a spaceship. It doesn't land you on the moon. Again, he was a NASA scientist of some kind. I don't know why he left. I mean, I don't know what the circumstances were. But clearly, I have to explain this to you, that the calculated joules of energy by mv squared of a rocket engine does not translate into the motion of the spaceship, that the only thing that works is Newton's third law, the action this way, action that way. The momentum's equal. The kinetic energies do not equal. Obviously, the kinetic energy is a fable. It isn't real.
if someone makes a model of a quantum theory of gravity that predicts things better, then we will think that that is one more step closer to truth.
And you won't listen to it. You won't pay any attention to it. I'll sit here for fucking 10 years now saying it, and now it'll be another 10, it'll be another whatever. I'll be long dead before you sit there and say, oh, let's accept reality, because none of this crap is going to happen. They're not going to have a quantum computer. They're not going to have flying cars. They're not going to have any of the crap they've been over-promising forever. They're never going to fucking Mars. Oh, God damn it. As people. Yeah, they're not going to arrive there as a person. Oh, fuck. All right. Enough of this bullshit. All right, so I'll, he never even got to the subject of Newton and gravity, so I guess I'll do some different parts. So maybe I should draw one on here somewhere. How did the hell that get in the way? All right, so I'll do that. I'll put a 1 here, and so then we'll be way ahead, right? Way ahead. And I'll get to it whenever I feel like it, frankly. So I'll stick a little 1 in here. There we go. There, part 1. Okay, so. Shit. Yeah, well, I like to use the other image as the icon, so. Because it has his name in it. So, yeah, maybe I'll do that anyway. So, fuck the 1. Yeah. Anyway, till the next time, such and so forth and whatnot. Did I tell you I hate it here on Earth? I just can't stand living among you people. You are so fucking stupid and dishonest. It's disgusting.